here we go, covalent nomenclature. Covalent bonds, remember, are the sharing of electrons. Sharing is caring. Instead of, like where we learned in ionic bonds, how the endings of the names change, covalent bonds still have the endings of their name changing, but they also have a prefix, and the prefixes are Greek. They're from the Greek prefixes, so they should look familiar to you. So 1 is mono, 2 is di, 3 is tri, like triangle, 4 is, do you know 4? It is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. And we're really not going to go past that. But that is something that you'll need to know in order to do covalent nomenclature. So a covalent bond is the sharing of electrons, usually between two non-metal elements. So when a non-metal and a non-metal are bonded together, they are a covalent bond. And remember, we talked about the staircase. So there are positive things and negative things over here, but covalent works a little bit differently from that. But for our purposes right now, if they both exist on the right side of the staircase, like carbon and oxygen, and including in that is also hydrogen, then these are the types of things that form covalent bonds. Okay? Okay, so how do we name a covalent bond? We have a couple of different rules here. They should look real familiar. The first one is the first element always gets its name directly off the periodic table, and the second element is going to end in IDE. So those are the same as the ionic rules, right? Then the third part here is that the second element always gets a prefix, no matter what that is. The first one doesn't have to have a prefix, but the second one must always have a prefix. And then, of course, once you do the first part 1 and 2, then you can add the proper prefix to the next one. So let's just do a couple of examples here. Here we have P3Cl5. The first element gets its name, phosphorus. The second element ends in IDE, so it's chlorine, so now we're at chloride. The second element always gets a prefix. Here I have 5, so this is pentachloride. And then there's a 3 on here, so this is triphosphorus. There we go. It's kind of a long one there. Triphosphorus pentachloride. All right, let's try this guy right here. That first element is xenon. The second one is fluorine, so it's going to become fluoride. And that little 9 right there makes that nona. So we have xenon, nona, fluoride. Okay, all right. All right, and so our last one right here, CO, the first one always gets its name, so that is carbon. And the second one, which will be oxygen, is now oxide. And even though there's no little numbers right there, there are ones. The second one always gets its name. So this is, we don't double vowel anything. So this is carbon monoxide or monooxide. Now if we want to determine the formula for a covalent name, we just have to go in reverse. So number 7 here says, what is the formula for carbon dioxide? So we know the first one is carbon, so let's see. When we look at the root word here on the second one, which is oxide, so that is oxygen, you have to you have to take away the IDE in order to get the second one. And then this is di, which means 2. Number 8, what is the formula for dihydrogen monoxide? So we have to look at the root word, hydrogen, and we have to look at this one, which is oxide, which is oxygen. Now this says dihydrogen, mono meaning 1, oxide. So the covalent name for water is dihydrogen monoxide. Number 9, what is the formula for pentanitrogen octahydride? So you have to look at the root word right here. That is nitrogen. And this one over here is hydride. If I remove that, that is hydrogen. So this is penta, which is 5, and octa, which is 8. So N5H8 is pentanitrogen octahydride, and that is covalent bonds.